Okay, so here in the second part of the first lesson of logarithmic functions, we're going to look at how we actually deal with logarithms mathematically. So not just the shape itself or the ideas of the properties, but more about how we can calculate things. Okay, so some quick refreshers. Y equals 2 to the x, that's our exponential version. Hey, it's inverse, the one we're going to start using is y equals log base 2 of x. Okay, notice that the base here is still the base over here. We call that the base. Okay, since logarithms and exponents are inverse to one another, we can use these two forms interchangeably. Sometimes it might be easy to calculate this kind of answer in exponential form. Sometimes it might be easier to use a logarithm to calculate something. And we can go back and forth between the two things. Okay, your base becomes your base. Okay, your exponent becomes the answer. And your whole number becomes the whole number here. Okay, it's going to take a little bit of practice to get used to where things go. But this is how we can calculate things with logarithms. Okay, to evaluate a logarithm in the form log base a of m. What we need to think is a to the power of something comes out to m. And the something, the thing over here, will be our answer. For example, if I want to know what log base 2 of 32 is, I need to think to myself, 2 to the power what comes out to 32? We really are going to just guess and check and say, 2 to the 3, 2 to the 4, 2 to the 5. What works? Well, that doesn't. That doesn't. 2 to the 4 doesn't work. 2 to the 5. Oh, 2 to the 5 works. Okay. So since 2 to the 5 is 32, we say that log base 2 of 32 is 5. 2 to the power 5 makes 32. The answer is 5. Okay, we'll try the next one. I need to think to myself, log base 3 of 729. So 3 to the power of something comes out to 729. Well, 3 to the what? I try. 3 to the 2, that's 9. 3 to the 3, no. 3 to the 4, no. 6, I guess, and check a little bit. I find out that 3 to the 6 is 729. So what does that mean? That means that log base 3 of 729 is 6. And this whole thing comes out to an answer of 6. Try the next one. Log base 9 of 3. 9 to what comes out to 3? Well, it's actually smaller than a star, which tells me it probably is a fraction. What fraction? 9 to the power what would be 3? Well, something I might recognize is that the square root of 9 is 3, right? So if I stop and think about that, the square root is like saying 9 to the half, right? Rational exponents. Okay, 9 to the half is 3. So what does that mean? That means that log base 9 of 3, the answer is 1/2. Because 9 to the half is 3. My answer is 1/2. Okay. Yeah, try some messier kind of things. Log 6. Okay, so let's take a look at the next one here. Log base 6 of the 4th root of 6. Now that's kind of messy to work with. So I might rewrite this as log base 6 of 6. And I know the 4th root is the same thing as saying 1/4, right? That's an equivalent expression. So now I'm thinking to myself, 6 to the power of what comes out to 6 to the power of 1/4? Well, that seems pretty obvious. That's a question mark. That thing I don't know has to be a quarter, right? So in other words, I'll go back to the question here. Log base 6 of 6 to the 1/4 is 1/4. Here, try one more. I don't want to rewrite this again. Log base 8. What is a half? Well, half is like saying, a root sign is like saying a half, right? So I'm thinking to myself, 8 to the power of what? Will come out to 8 to the 1/2. Well, the what has to be a half, right? So that tells me that log base 8 of 8 to the 1/2 is 1/2. Okay, and that's we can do some basic ones here. Okay, some other things we can do. Things that have operations between them. Same idea, we just got parts and pieces now. So I'm thinking to myself, 2 to the power of what is 16? Guess and check. 2 to the 2, 2 to the 3, 2 to the 4. 2 to the 4 is 16. So that whole thing is 4. Minus 3 to the what is 27. I'll try again. 3 to the 2, no. 3 to the 3. Yeah, that'll work. 3 to the 3. So this whole thing is 3. And what's 4 minus 3? Well, that's 1. Okay, let's try the next one. Log base 4 is 64. 4 to the power of what makes 64? So 4 to the 2, 4 to the 3, 4 to the 3 will work. Okay, that's that piece. 7 to what exponent comes out to 1? So I'm thinking 7 to the what comes out to 1? Well, the only thing that makes it come out to 1 is if it's 7 to the power of 0, right? So this whole thing must be 0. And 3 plus 0 is 3. Okay, so you can do operations between logarithms. Just do each part separately. Okay, last little thing. Sometimes we deal with our calculators, and our calculators are programmed to do the standard base. We call that base 10. So when you don't see a base, like over here, log x, it really means log base 10 of x. And that's what our calculators are programmed. Okay, so if you want to find a logarithm using your calculator, it can only do base 10 once. And if you don't see a base, it's assumed to be a base 10. So for example, these ones here are log of 1,000. That's assumed, oh, it's log base 10. We don't show that though. Okay, our calculators will do these ones. 10 to the power of what is 1,000? Well, if I just type that in, log 1,000, I'll get 3. And sure enough, 10 to the 3 is 1,000. Okay, which we could do by hand. But ones like this one, log of 25, I can't do that by hand because there's nothing 10 to the power of anything will not make 25. But using my calculator, log of 25 is 1.40, big long decimal there, right? I'm going to try the last one, use my calculator. And log of 0.001, I end up with negative 3. And you can get negatives, there's nothing wrong with negatives. When you get values below 1, you end up with negative answers. Okay? And last thing, no application here. Here we got fog. It can reduce the intensity of oncoming headlights. Turns out the distance in meters and the headlight intensity are related to each other by a log function. Okay, so for part A here, how far away is a car whose headlight intensity is 50 lumens? We can figure that out. And we're using our equation here. The intensity is 50, so 50 over 125. Which I can turn that into a decimal just to make my life a little bit easier. Or you can put it in brackets if you want to. There's nothing wrong with using the brackets when you're dividing by on your calculator. 50 divided by 0.5 is 0.4. I punch that in all the way it looks, and I end up with 66.5 meters. Okay, and actually, I think I took part B off your lesson, so don't worry about part B. Okay, just to get an idea of how we can use logs, how we can change it from exponential to logarithmic form, and how we can use our calculator at times when it's base 10. Okay, that's sort of our intro to logs. So we have 3 more lessons, log laws, solving questions, and some applications. So give the homework a try. It should be pretty quick. If you have questions, come by and see me or send me an email, and we'll go from there.